So today's topic is thriving towards green energy. I am more concentrating on solar and battery storage system. Okay. Now today's world we are facing the global warming. What is the main reason for the global warming? If you think about that one, the main reason is usage of fossil fuels. So nowadays we are using more fossil fuels. Due to the fossil fuels, the globe is warming up and more heat is developed. So we need to go for alternate energy, that is renewable energy sources like wind generators, solar system, tidal power, hydropower plants, increasing the hydropower plants. Then we can reduce the global warming. So to create the awareness about the global warming reduction and encouraging the more renewable energy sources, and also Malaysia plan to increase the storage system like batteries. They have the plan by 2030 and 2035 how to increase the battery storage and what is the need of battery and charging stations for electric vehicle with the help of solar. So those things we are going to cover today. So we can generate your own clean energy, renewable energy, to reduce the carbon dioxide emission and reducing carbon footprint. If you see the carbon footprint, if you use more meat, cow meat or ox meat, then it will increase more carbon footprints. And usage of vegetables and nuts will reduce the carbon footprint. All this will affect our climate. So to reduce these effects, we are going for the renewable energy sources. And Malaysia supply industry, MAHSA 2.0, they have a certain plan. So far, more hydro technologies are used up to 18%. By 2025, they increase the renewable energy source with the help of solar. Their plan is to increase the renewable energy power generation by 20% by 2025. And the power demand by 2030, it will be 47 gigawatts. So they are planning to increase the solar power installations by 2030. Then battery storage. 2019, the 100 gigawatt hour is needed at that time. By 2030, they need 100 to 165 gigawatt hour. Since the number of houses will be increased 5 million to 8.35 million by 2030 year. Then 2030, so we need high growth in the battery storage system. So they need to increase from 100 to 421 gigawatt hour. So they plan to increase the more power battery generation to increase the compensate the demands. Then throughout the world and other than Asia, Europe, China, US, the annual EV battery demand, how much? By 2020, it is around 100 gigawatt hour. By 2035, it will be increased 6 times that of 100. So it need around 600 to 700 gigawatt hour required. So how to compensate these things? So by increasing the storage system, that is increasing more power battery generation. So that's why the Malaysia plan to increase the battery generation. Okay, so Malaysia, they increase the battery storage the roadmap yearly from 2030 to 2035. So yearly they wanted to increase capacity of 100 megawatts. So in each year, 100 megawatt, they plan to increase the battery storage. Then Malaysia renewable energy target by 2025, it will be 31% and 2035, 40%. Only renewable energy. So they plan to install more solar power plants. Then what are the benefits of battery storage? Renewable generators, if you go for more renewable energy, it will increase the cost. So we can go for battery storage. Then system operation, flexible power release when needed, then recovery power for power grid failures. So due to these advantages in system operation, then investment benefits, we no need to go for more congested network power grid. So that one we can defer, and also defer investment on capacity and energy shifting. So due to these reasons, Malaysia plan to go for more batteries. Also, another technology called as battery swapping. Nowadays, the number of electric vehicles are enormously increasing day by day. So for electric vehicle, battery swapping is very easy. So how to do the battery swapping? So here, the fully charged battery is a dark blue line. Battery swapping service required is white line. Energy, thin blue color, and new standard battery, the gray color. So new standard battery manufactured from the EV and battery manufacturers and delivered to battery charging factories. So in the battery charging factories, the batteries are getting charged with the help of renewable energy sources and grid. Then in the battery swapping station, the batteries get the power from smart grid and they can give to the EV or EV users. Also, battery swapping van. So the vans can get the batteries from battery charging factory, battery swapping stations, and deliver to EV users or houses also if we request through battery swapping service app. And that battery swapping service app will communicate with the battery swapping service management system, and it will give information to the battery swapping van. So to deliver the batteries to EV users or EV user homes itself. Okay, so it will take very few minutes only to swap the batteries. Okay, so due to these reasons, the Malaysia going to increase the number of battery manufacturing factories. Okay, then solar. So solar is one of the main renewable energy sources. Here, basically three types of solar systems. One is standalone system or off-grid. That is, this system is not connected with the grid. Okay, this is entirely standalone. Here, the number of solar panels you can design after calculating the energy requirement for your houses. Okay, then based on that one energy requirement, you can size the solar PV panels. Then charge controller. So charge controller are also very important part of the system. Why means the solar sunlight is not stable. From morning to evening, the sunlight intensity is keep on changing. So the power generation also not constant, not stable. So we need to get the stable output. To get the stable output, we are using the solar charge controllers. So that is one purpose. Another purpose, if you see, during evening time or night time, there may be possibility of power reversal, that is power from battery to solar panels. Then if the power flows like that, then that will damage your solar panels. To avoid the power reversal from battery to solar panel, we are using the charge controllers. So the charge controllers avoid this reversal power flow. Then another advantage is keep the battery within the limits. That is, the charge controller will not permit battery to overcharging. If the fully charge means the charge controller cut off the charging of batteries. Also, keep tracking the battery voltage. If the battery voltage goes below the certain value, it immediately gives signal and charging the battery. So for that purpose, using the charge controllers. And the solar panels only producing the DC, isn't it? But our house appliances, we are using the AC. So we need to convert DC to AC. So for that purpose, we are using the inverters. So inverter converts DC to AC. Okay. And also charge controller directly give power to DC loads, also lighting loads we can connect. Okay, so this one completely standalone system, not connected to the grid. Next one is grid connected system. So only grid connected system. We are not using any batteries in this system. Okay, during daytime, the solar panels generate electricity and feed power to our household appliances. And during night time, we will not get any sunlight, isn't it? So we can get the power from the grid during the night time to our household appliances. So that is the grid connected system. Next, the third one is hybrid system. That is combination of standalone system and the grid connection system. So here the solar panels will charge the batteries, also feed power to our household appliances. And night time we can get the charge from battery, or we can get power from grid. So this is the combination of standalone system and grid connected system. Okay. So then net metering concept. Here in Malaysia, they introduced the net metering concept. We can install the net meter in our homes. The solar will generate the electricity, isn't it? So that electricity we can use for our house. Extra energy that can be exported to our grid. So that will be calculated by the net meter. So how much power we export to grid, that is calculated by net meter. And also how much power we utilize from the grid, that also calculated. So energy we consume, if you subtract, then remaining energy, how much energy we export to grid, that will be returned back to our account by the government. Okay, excess energy can export. Then batteries. So batteries are storage elements, different type of batteries available. And for solar system, mainly deep cycle batteries we are using. So some kind of batteries like lead acid, lithium ion, and salt water. These are different type of batteries. How it perform? Lead acid battery capacity is small, but lithium ion is the largest capacity, and but cost is high for lithium ion. Lead acid is low cost compared to lithium ion and salt water. Maintenance, little maintenance for lithium ion and salt water, but requires frequent maintenance for lead acid. And lifetime also, lithium ion is longest, better compared to lead acid. Salt water in between lead acid and lithium ion. So these are different types and comparison. Then important parameters, we should know the important parameters regarding the batteries. One is main one is C rate. Actually, if you see the batteries will be telling in terms of C rate only. So, what is the C rate? So, how long it can charge and how long it can discharge? That is said to be the C rate. For example, small t is the time period. Time period t equal to 1 over CR, 1 divided by CR. CR is C rate. So it is mentioned in the battery sheets. Okay. So to view in hours, 1 over CR. To view in minutes, how many minutes it takes to charge or discharge means 60 minutes over CR. If you substitute the CR value, then you can find how long it takes to charge or discharge. So that is called the C rate. Okay, for example, 1C rate. 1C rate means within 1 hour. Within 1 hour, it can charge or discharge. Okay, for a battery with a capacity of 100 ampere hour. So, for example, battery having 100 ampere hours capacity. Then 1C rate means within 1 hour it will charge and discharge. Then what is the meaning of 5C rate? 5C rate means 1 over 5. 1 over 5 is within 1 over 5 minutes time it will charge 100 amperes, or with 1 hour it charge 500 amperes. So that is the meaning of 5C. Similarly, C over 2. What is the C over 2 means? Within 1 hour it can charge up to 50 amperes. Within 1 hour it can charge up to 50 ampere, or within 2 hours it can charge fully, that is 100 ampere hours. So that is the meaning of C over 2. Okay. Likewise, 30C, 20C, 10C, like that. 10C means within 6 minutes it will charge. So above 1C are said to be fast charging, and below 1C, that is 0.5C, 0.2C, up to 0.05C, these are said to be slow charging. Okay. Also, the battery C rating is the measurement of current in which a battery is charged and discharged at that point. The capacity of battery is generally rated and labeled at 1C rate. This means fully charged battery with a capacity of 10 ampere hours should be able to provide 10 amperes for 1 hour. Okay, 1C means the battery is fully charged and discharged within 1 hour. 2C is within 30 minutes it will charge, and so on. Okay, 10C means within 6 minutes, 100C means in 36 seconds it will charge. And for a 15 kilowatt hour battery, 1C charge or discharge rate means pumping in or taking out power at 15 kilowatt, can charge or drain battery fully in 1 hour. So 0% and 100%. 2C means within 30 minutes, 4C within 15 minutes. So these are some examples for C rate. And state of charge. So it is a measure of percentage of battery charge. That is, in the mobile phones you may see, isn't it? How many percentage, 50%, 100%, 80%, like that. So 0% means completely drained, like that. We can say, so 0% discharge fully, 100% fully charged battery. Okay. Then output voltage of battery packs varies with its state of charge. So output voltage is different and charging is different. Completely charging or completely drained, that is different. So fully charged means 56 voltage. Nearly zero means 43 voltage. So within 43 to 56, not going below 43 volt. If it goes below 43 volt means your battery will going to drain, that is damage. So we have to keep the battery voltage between 43 and 56 volts. So you should not let the battery go below 43 volts. That will disturb your battery performance. Okay, then SOH means state of health, how health it is. So it represents a measure of the battery's ability to store and deliver electrical energy compared with a new battery. Actually, initially the state of health is high, and day by day the state of health will decrease, depends upon the battery rating and its capacity. So another system is battery management system. For lithium-ion batteries, small batteries, if you add together and more number of batteries we can add it to form a big battery bank, so that we can give power to our electric vehicles and trucks like that. So we need to continuously monitor the battery parameters, that is state of health and state of charge. Continuously we need to monitor with the help of battery management system. So that is very important. For example, if some battery cells are lower capacity, then how it affects the performance of the battery. Here the middle two batteries are lower capacity cells. They will charge faster compared to normal healthy batteries. Okay, so what is the disadvantage? If the lower capacity cells charge faster, then it will indicate BMS, that is fully charged. But other batteries still 90% only. Okay, so this one affects its performance, since other batteries only 90%, but this two lower capacity cells 100%. So immediately what happens? It stops charging. So that is one disadvantage. Bottom figure, the lower capacity cells discharge faster also, discharging faster. So unused capacity is still in the healthy batteries. Okay, again it will give signal to BMS and gets charging, even though other batteries are still having charge. So this will affect its performance of battery. Okay, then state of health due to aging. So first figure, state of health is 100%, that is new battery. After due to aging, the SOH decreases 100% to 80%, 50%, 25%, 15, and then 0 like that. Day by day or monthly or yearly, depends upon the battery capacity and its nature. It state of health aging will decreases. Then if you are a manufacturer of battery, then how to test the batteries? Different type of testing available. Since after do the testing, then only you can submit to the government for approval. So what are the different type of testing available? Open circuit voltage test is available. With the help of Arduino, we can make this type of testing. So Arduino is connected via USB to the laptops, which runs a Python script. So the Python script that reads the open circuit voltage continuously from the Arduino and writes them in a separate file. So based on that one, we can further analyze its open circuit. Okay. Then thermal imaging. This is another type of test. From this type of test, we can identify overheating, whether the battery is overheating or not, whether inadequate heat sinking or not, whether sufficient or not. Then undersized current conductors and interference from neighboring cells or devices. So these the different problems we can identify with the help of the thermal imaging based on the different color coding. And another testing is electromagnetic compatibility, whether your battery is electromagnetically compatible or not. So what are the different parameters? Operating frequency, circuit layouts, then enclosure design, avoidance of designs with high transient currents. So these are different design parameters we need to consider for electromagnetic compatibility testing. Then sensitive parts may be physically separated from sources of interference and properly sealed metal box, shielded with metal foil, filter out the noise. So these are the things we need to consider for testing of electromagnetic. Then cycle testing. So charging, discharging that cycle. Simulate the operating conditions in temperature is allowed to rise. How much temperature it can withstand like that. Then depth of discharge restricted. Then how the cycle life will get affected. What are different parameters? Temperature, capacity of the battery, impedance, power output, then discharge rate. These can be continuously monitoring and recorded. It takes 5 hours for a controlled, fully charged discharge cycle for the cycle test. So these are the different testing we need to do for batteries before submitting to the government for approval. Then chargers, EV electric vehicle chargers. Different type of chargers available, level 1, level 2 and level 3 mostly categorized like this. The level 1 charging, here the power grid is connected with the electric vehicle. Okay, then why we need EVSE? EVSE is electric vehicle storage equipment, supply equipment. This one is the interface between the power socket and the electric vehicle. It will check whether any earth fault is there or properly connected with the electric vehicle or not. Everything the EVSE will check to avoid any shock to our EV user. Okay, so EVSE equipment is very important in case of the charging. So in future, there is more demand for EV charging stations. Okay, so you are the future engineers. You can think about those things. Whether after some time the petrol diesel will going down, so EV charging stations will coming up. So plan now itself. Okay, so EVSE uses a standard AC line current or single phase 230 volt at 15 amps. So continuously 15 amps it will deliver at 230 volt single phase AC. AC to DC power conversion taking place in the vehicle. It takes around 19 hours. See how long? Very slow charger, isn't it? It takes 19 hours to charge your EV batteries. Then level 2 charging, it can accept a more powerful single phase line at 240 volt, 15 amps to 15 to 32 amps. This one slightly better than level 1 charging. It takes around 6 hours. 6 hours to charge. Then last one is level 3 charging, AC to DC power conversion taking place in the charging station. So it is possible to supply a high voltage DC line. So high voltage DC line. These are public charging stations, and within 30 minutes it can charge. So this is the fastest charging station level charge. Then EVSE. What is the importance of EVSE? It provides several safety features. Power pins not hot until so EVSE will communicate with the electric vehicle. Okay, whether the EV is ready or not. Okay, and I can deliver this much current only. Whether your EV can accept this much current or not. So that kind of communication between the grid and EV with the help of EVSE will taking place. And ground fault circuit interrupt. Then graceful startup or shutdown, then ground verification, the pilot signal detection and verification. So one pin is there. So that pin is used to detect the signals. Pulse, for example, pulse width modulation signal, PWM signal. So we can change the duty cycle and check the voltage level. Based on the voltage level, it will know whether the EV is ready or not. Okay, next we will see those things only. Then stuck relay detection, plug rater for many plug-in or disconnect cycles. So for this purpose, we are using the electric vehicle supply equipment. So here, the figure shows one kind of charge block. It has 2 pins at the top and middle 3 pins and bottom another 2 pins. Okay. First pin, first row is the control pilot. Okay. It carries the data signal, that is square wave signal, as I said earlier, pulse width signal. So we can change the duty cycle of the pulse width. That carries the data, that carries negotiation, whether EV is ready or not. So that kind of communication between the grid and EV with the help of EVAC. Okay, and first row, second pin is the proximity pilot. Proximity pilot is used to confirm whether EV is properly connected with properly latched or not, like that. And middle 3, line 1, L2, L3, and bottom 2, neutral and F pins. Okay, so that is the J1772 connector. So it is nothing but a charging. It covers general physical, electrical, and performance requirements. So as we saw earlier, level 1, 2, and 3 charges. Here the pilot signal, that 1 kilohertz pilot is communicate with the EVSC and EV. The duty cycle, EVSC defines the maximum current available to the EV. So then proximity, it checks whether the charger is securely connected to the vehicle or not. So condition of charger connection. So this is the important. So depends upon the pilot high. That is plus 12 volt. Plus 12 volt means it is not connected. Plus 9 volt. Plus 9 volt means EV is connected and ready for charging, not at charging. 9 volt is ready for charging but not at connected. Plus 6 volt means EV is charging. Okay, so these are the different levels, different states of depends upon the voltage, whether connected or EV not connected, EV is ready for charging, not charging, like that. Depends upon the voltage level, we can the EVSC will give the signals. How to calculate the duty cycle? For example, for 18 amperes, duty cycle is 30%. How it will be calculated? Ampere equal to duty cycle times 0.6. So if you duty cycle equal to ampere over 0.6. Ampere is 18, means 18 over 0.6 is 30. So 30% is the duty cycle. Okay. So depends upon this formula, we can calculate the duty cycle. And how it negotiates. This will be, we measure from the say the CRO or the MATLAB. Okay. For example, 12 volt signal line is running, that is straight. So this one, EVSC is ready, but electric vehicle is not connected. That is under state A. State A, EVSC is ready, but EV not connected. Then 9 volt. 9 volt, it takes some delay from 12 volt to 9 volt. Then at 9 volt, that is state B. State B, EVSC is ready, Now EV is connected. So EV connected with the grid. Okay. Then 9 volt to 6 volt. 6 volt is under state C. State C, EVSE is ready. EV is charging. So now EV is charging, it gets charged from the grid continuously. When it is fully charged, then the voltage increase from 6 to 9 volt. 6 to 9 volt and stop the charging. Okay. At 9 volt, EV is ready, but EV connected, but now stop the charging. Then 9 volt to 12 volt. So now 12 volt EV plug had been disconnected. Okay, so depends upon the voltage level, the EVSC, the EV is connected with the grid or not through some interface. That is, EVSC is the interface. Through that interface, the grid is easily communicate with the electric vehicle through the connectors. Okay, so in some cases, the EV having onboard charger. Okay, so simply we can connect with the grid through the connectors. Off-board charger means in the EV, the charge conversion is not available. In the plug point is the converter is available. Okay, so it depends upon whether it is onboard charger or off-board charger. We can charging the electric vehicle with the help of EVSE as an interface. So today, what are things you take from this webinar means the awareness for renewable energy sources. Okay, so to reduce the global warming, we can plan for renewable energy sources, and in future definitely more electric vehicles will be coming up. Okay, almost the entire world will go for electric vehicles in future. So day by day, the fossil fuel vehicles will coming down. After certain years, completely the fully electric vehicle will be replacing the petrol and diesel vehicle. Okay, then solar system we can easily implement in our houses and in our universities and colleges like that. Moreover, MAHSA, our university completely no plastic. So plastic free zone in Malaysia. And also we go for the Green Building Index, GPI, Green Building Index. So we need to consider certain things so that we can apply for Green Building Index. Certain agencies will give the points. If we achieve certain target, then we can get silver medal or gold or platinum like that. They will, for that we need to grow trees or grow plants in the building, then go for renewable energy sources, solar, wind, like that we can install in our university. Hydro power plant also, mini hydro power plant also you can install in your colleges or universities, and growing more plantations and avoid the plastics. You can conducting more lectures to the students and public about the awareness about the green environment, green campus. So with that we can get the green building index. Okay, and do more renewable energy projects in our campus. So like that you can also encourage your students and staff, public also, so that we can reduce the global warming. And batteries, so in Malaysia they are increasing the battery manufacturing companies and generating more batteries for flexible power modes to our houses and industries like that. So charging electric vehicle can design the electric vehicles with the help of batteries. We can get the charging, and we can develop the charging stations. Solar based charging stations also we can implement in our universities. So we plan to install solar based charging stations in our campus. Okay. So with this, I conclude my today's webinar. Thank you.
Thank you very much, sir. Thank you. Students, if you have any doubts, you can ask. Sir, I have one practical difficulty, sir.
What is?
For students having interest in doing electric vehicles, particularly in the battery section,
Okay.
but they need to overcome the recent issues, that is the explosion. Some electric vehicle batteries have exploded during charging. So, in which area we need to concentrate, sir?
Yeah, the main reason is we should properly connect the batteries, and to avoid the overheating, proper the shielding and proper ventilation and proper cooling is very, very important. Liquid cooling as well as air cooling is very essential for to avoid the explosion. Properly we need to handle the batteries. Improper means definitely explosion will be happening.
Okay, sir. So we are working particularly on electrolyte side, sir. Our students have some idea to replace that liquid electrolyte into powderized form. So during from our observation from recent literatures, we have identified that these electrolytes, that is liquid electrolytes, are the major reason for the explosion while charging. But in Tesla itself, they are in very initial stage to develop that powderized form of electrolytes. Is there any possibilities to create that powderized form, sir, electrolyte in powderized form?
Yeah, slowly they are doing the research in those areas.
Yes, sir.
Coming up on this one.
Okay. Okay, sir. Thank you, sir.
Okay, thank you.
Thank you very much, sir. On behalf of PS College of Engineering Technology, I would like to thank Professor Kasirajan Kasipandian from MAHSA University, Malaysia, for this wonderful technical webinar. Thank you very much, sir.
Thank you.
And I would like to thank Professor Dr. S. Rajasekharan for organizing this webinar, sir. Thank you.
Thank you, organizers, and thank you, Professor Rajasekharan, sir. Thank you, participants.
Thank you, sir. Thank you very much.
Thank you.